Okay guys, so as I was talking about the calculation of RC, these are the equations by which we will calculate RC. So as I said, we need to calculate the moment at point B. In order to calculate the moment at point B, we have to analyze what are the forces that are acting on the beam, not by the beam. Now the VD that we calculated right now is the force that is applied on this bar by the beam. It's by the beam, it's not on the beam. So we need to calculate what's the force acting on the beam, and that would definitely be the opposite in direction. So the VD will be acting on beam also, but it will be in the opposite direction. It will be in the negative, it will be in the downward direction. And according to my notation, the downward forces are always positive, the upward forces are negative, and the clockwise rotation is positive and anti-clockwise is negative. So now we go ahead and write this thing down, which is basically the moment at B is equal to 0. As you can see that there is no moment at this point, and the bar is pretty much steady, and that is one of the requirements for this question, for this crane to work. So this is basically the equation. According to this equation, we get, so there are two forces that are acting in the vertical direction. One is VD and the other is RC in the Y direction. I mean the component of RC in the Y direction. All the other forces are in the X direction. That wouldn't really create any moment because they are acting axially on this beam. So they will not definitely create any moment. So the moment created by VDE, which is in the negative direction, I should draw it like that. So this is also VD, but that is acting downward. Okay, not negative direction, but it's opposite direction. So this VD is acting downwards onto the beam, and it will create a moment in clockwise direction. So that will be positive, right? So we take this as positive. Now RC, as I told you, the first postulate which tells you that we should never put a sign for the unknown forces. Now RC is an unknown force, and therefore we take it as positive. We just add it. We don't put it as negative, even though we know that the force will be acting upwards, right? Here, that will negate the force which is acting downward, and because of that, at point B, the moment generated will be in this direction, which is anti-clockwise, and therefore it should be negative. But according to the first postulate, we will not put any sign there, and therefore we write this equation equal to 0, and we solve for RC. We find out the RC is negative, which means it is acting in the upward direction, right? As I said in my notation, up forces negative and down forces positive. So we found RC to be that much. Now after finding RC, we have to calculate the internal forces at point H. We make a section at point H, and then we try to find out which would be the easier way to calculate the reactions at that point, the internal reactions. Now we know RC, right? So we can easily find the components of RC in X and Y direction. So we know the forces that are acting here, right? So let me just write it down with black, of course. Okay, so I wrote down the reactions at this point, which is at point C. And at point C we have a VC and NC because of this reaction RC, and we know that because we know RC, and we can always do RC sine theta and RC cos theta in order to find Y component and X component respectively. Okay, so we know these forces. We know VD and ND, which are acting on the beam, right? And then we also we do not know the reactions which would be acting at the internal forces at point H. So that is just one unknown. Now in order to, if we take this particular bar for our analysis, we do not know VB, we do not know NB, and we also do not know the reactions acting, the internal forces acting at point H. So there will be two unknowns, in fact 4 unknowns. So it will be difficult to solve. Therefore we take the other part of the bar. So let me draw that part separately over here, okay, and then we'll analyze. Okay, so I'll just remove this because we know how it works. If you want to refer it, you can always go back and pause and copy down. Okay, so I've cleared up everything and written all the known values at that point, and I have created this section which is from point H to point D, right? So from point H to point D, this is the section that we are analyzing. We know all the forces. The easiest way to do it again is to do the summation of fx. So I'll just start over here. Summation of f of x is equal to 0, and summation of fy is equal to 0, and the moment also equal to 0. So let's do this. Summation of f of x is equal to 0, so we'll see all the forces that are acting on the x direction and add them all and equate that to 0. So let's do that. Okay, so I have gone through solving all these unknowns, so we'll go one by one. So as I told you, we have to go through fx is equal to 0, summation of fx, so we calculate all the x, all the forces acting on the x direction. So one of it is nh. Of course we don't know this, so we will not put any sign, so it will always be positive. And the other one is 7100. We know that it is acting on the right hand side, which is the positive x direction, and there is 9800, which is acting on the left hand side, which will be a negative x direction. So we write it down like that. So nh plus 7100 minus 9800 is equal to 0. We calculate this and we found nh to be 2700 newtons. Now this 2700 newton is positive, which means the force is acting on the right hand side. So at that point the force is acting in this direction. Okay, so it's like the force which is acting down on this beam is basically trying to tear it apart. It's trying to tear it apart by 2700 newtons forces. So while going ahead and doing the stress analysis, if your material is not strong enough, it might break at that point if your yield stress is lower than 2700 newtons. Well, the fy is equal to 0, summation fy is equal to 0 equations are these, and that one was the fx. Oh, that's a long one. This is fy, and this is for the moment. So fy, we calculate vh. Now since the moment is being applied at that point we have an mh, which is an unknown, so we'll not really, not the moment, we're talking about the forces, right? So at that point vh is being not at that point, so we forgot about the points, right? I'm getting confused, I'm sorry. So vh, we talk about all the forces which are acting on the y direction. So one of the forces is vh, which is acting, I don't know where, because it is an unknown, so we'll give a positive value there. The piston is pushing this beam up, so that will be a negative force, so we have a negative 26,496.7, and then there is a force which is acting downwards, which is a force acted upon by the inverted L beam onto this beam, and that is downward, so it is positive, so we have a positive 5800 equal to 0. We calculate that, we get a VH equal to positive. If it is positive, which means that the force acting at that position is downwards, so it will be in this direction, not that direction, right? So let's get rid of it. Okay, and then we found that it's a tearing apart kind of force, so this direction is also wrong. We in order to find the moment, we calculate the moment at point H. Oh no. Okay, that looks like H a little bit. At point H we calculate, so we don't know the direction of MH, so we'll just keep it positive. Then there is this 26,000 496.7 force acting upward, so this will create anti-clockwise at H. So anti-clockwise is always negative, multiplied by 0.4 is the distance, as you can see, 0.4. And then we have another force acting downwards. This will create a clockwise, and this total distance is 1.8, so you multiply 1.8 and take it positive. When you do all this calculation, you get mH to be a positive moment of 14.68 Newton meter, and that is in the clockwise direction, so that is the wrong direction again. So it'll be like that, right? Let me get rid of this. So there we go, we found out our values of NH, which is the internal forces on the X direction, 2700 going towards the right. VH is a force acting downwards, which is 20,616.7, and we have a moment of 14.68 at that point. So there you go, that is the internal forces. To sum it all, I will go through the whole thing again. First, remember the postulates, right? Postulates are very important. Second, draw the free body diagram, right? In free body diagram, you have to take care of all the joints, right? And you have also to take care of the reaction forces that are acting at each joint. So you can use the trick of putting yourself, you remember the guy which I hung at this position in order to calculate, in order to find how the reactions would apply. Sometimes you can, since these are very practical example, there could be situations in which you might have some intuition by experience. Also, you can find out the reaction if you put yourself in place of joints, and you can imagine, okay, what are the ways I'll have to pull or push in order to keep the component at equilibrium. So you can always assume, so you have so after doing that, you will be able to find the reactions, which I somehow will be able to write down with my mouse, which is always difficult. Okay, so you do the free body diagram, you found the reactions, and then third, actual calculation of reactions. So one of the ways calculating the moment is always a very easy way of calculating reactions. So you have to calculate the values for reaction, and then of course you do the section, like you cut the beam at the point where you want to calculate the internal loading, and then you put the equilibrium equations into play. Equilibrium, I wouldn't write the whole thing, it would take like 3 hours. Equation, oh, okay, yeah, equilibrium equation. So these are the 5 steps that you must follow all the time, and you see it's very easy. Keep each and every thing simple, and think logically. For example, at this point, if you would have just taken VD to be acting upwards, you might have got a different wrong answer. But keep in mind that whenever you're analyzing one section, you have to see what are the external forces acting on the beam, not done by the beam. Okay, remember the 2 postulates. One postulate was to give positive sign to all the unknowns, and the second was what was that? Always consider the external forces, not the internal forces, right? A very good example of this external internal forces I will take care of in another example, the one which I discussed initially, the rope example, and I think things will get clearer at that time. So for now, I think this would be the end of the video. I hope you understood, and I really sincerely hope that it might help you people do, even if I didn't do a great job, at least the intention was sincere, and it was to help you guys. So I hope you find help in these video, and I wish good luck to you people. Have a great day or night or whatever time it is. Take care. Bye.